Hello and welcome to helpyourmath.com. In this video, we are going to review 45, 45, 90-degree right triangles. This is just a review. For a more complete picture of these triangles, please watch my other video on right triangle trigonometry. Let's get started. When we have a 45, 45, 90-degree right triangle, what we know is that the two legs are the same length. We know this because the two angles are the same length, and the base angle theorem tells us that therefore the two legs are also going to be the same length. So they will always have that same value. If we know one leg is 7, the other leg is 7. If one leg is 4.2, the other leg is 4.2. But the question is, okay, well, what is the ratio with the hypotenuse? So if the legs have lengths of 1, the hypotenuse is the square root of 2. And you can quickly derive this using Pythagorean theorem. It's not that bad. So we say that the ratio of the legs and the hypotenuse are 1, 1, and square root of 2. Now, if you watched my brief video on the 30, 60, 90 triangles, you know that I showed how to calculate these in two different ways. I like using algebra and setting up algebraic equations. So when I do this, instead of 1, 1 root 2, I use x root 2, and then I can just set up these little equations that make it, for me, a little bit nicer. Let's go ahead and look at some examples of these. Okay, so one leg is 25 centimeters. So we're going to set up our triangle. We have 45 degrees, 45 degrees, and one leg is 25 centimeters. Now we want to find the remaining side length. So we already know what the other leg is because the other leg is the same length as the other leg. So the other leg is 25 centimeters. Now the question is, what is the hypotenuse? So the hypotenuse, again, I like to set up my little equation. We have x root 2, and what I know is that this is 25 and this is 25. So because we know that x is equal to 25, then that means that x root 2 is equal to, let's substitute in 25 for x, 25 radical 2. So the hypotenuse is 25 radical 2 centimeters. Not so bad, right? This is manageable. Let's look at another example. Here we're told that the hypotenuse is 13 square root of 2. So I'm going to set up my triangle. This is 45 degrees. This is 45 degrees. This is my right angle. And the hypotenuse is opposite the right angle, so that's going to go right here. Now what I know is that if this side length is x, this side length is x, right? I get to use the same variable because we know they have to be the same. Now let's go ahead and set up our ratio, x root 2. And what we know is we know this. We know that x root 2 is equal to, oh, I don't know why I wrote a 3 there. I said 2 and wrote 3, that's weird. X root 2 is equal to 13 radical 2. Well, what do we want to know? We want to know the value of x. Let's get x by itself. We're going to divide both sides by the square root of 2. That's going to cancel here. Oh, look, it cancels over here, and we end up with x equals 13. So what this means is that we have the ratio 13, 13, 13 radical 2. And we know that the length of both legs have a length, and we don't have units here, so we're just going to say of 13, and that's going to be it, 13. One more example. The hypotenuse is 24. Now you might be saying, woo, that's nice. Look, it's not irrational. Yeah, but that means that the legs are going to be, so we're going to have to do a little work here. What am I doing? Trying to talk and draw at the same time, which is not working out for me. Okay, so here we go. We know in this ratio of x root 2, where the legs are x's, and this is the x root 2, we know that this x root 2 is equal to 24. Okay, so let's get x by itself. We're going to divide both sides by the square root of 2. That's going to cancel over here. That will not cancel over here. We want to rationalize the denominator, so I will multiply both the numerator and denominator by the square root of 2. This gives me 24 root 2 over 2, and that can be simplified. Aha! We figured out that x is equal to 12 radical 2, so I know this leg is 12 radical 2, and I know this leg is 12 radical 2. So I can say the length of each leg is 12 radical 2. Voila. These have been examples of finding the remaining sides when we have a 45, 45, 90 degree right triangle. Thank you for stopping.